Okay, this is Durward King with ELC 117, and this is January 13, and we're on our third day, and we're going to wrap up the safety chapter, go into chapter 1, and start getting into the to the heart of our subject. So let's get the okay. And Nathan, this is the same document, the safety chapter that's in Moodle. You can view it right on your smartphone. Okay, so we're rolling here. Just a couple little minor things that I didn't touch on before we wrap this chapter up. On the lockout tag out, let's get the high spots in the lockout tag out requirements. Lockout tag out is mentioned in here, but I put a PowerPoint in Moodle for you right here, and let's hit the high spots. I don't want to take a lot of time on it. You can read it on your own, and there is a worksheet to do. You can do it in Moodle. But let's get some high spots with this. And I'm going to go through quickly, try to get us right on to the heart of what we're after here, is to get on to the devices you can wire up, knowing how to read the symbols and hook them up and all that good stuff. So again, watch, pay good close attention, don't miss any of this stuff. This is the kind of thing that can make you lose a job. It's bad to get a job and then lose it over something like this unnecessary. So does everybody have a mask? Make sure you put your mask. You got to keep it on the whole time. So, over your nose completely. Yeah. I know it's a hassle. I get tired of breathing my own hard air too. I do. But if we have an outbreak, it's going to chunk us into online instantly. You won't get any hands on. That ain't good. Not good at all. You can ask people that's done it. You can learn head knowledge, but you don't get the hands on that way. So anyway, so for lockout tag out, as you see right there, there's a lock device on that panel, and it's like what I showed you the other day. One of these. It's a multi-hole hasp like that. Several people can use. Is to prevent unexpected startup of a machine. It's required whenever somebody removes a bypass or a guard or a safety device on the machine, you're supposed to lock it out. If a person could get their part of their body into a machine in the danger zone, it needs to be locked out. There are exceptions if you're going to do minor adjustments, and that's going to be up to your supervisor. What can you get in there and do with it on? And again, minor adjustments, and that's going to be up to your boss. Now, for things that plug in, you're allowed not to lock it out, but we actually do lock out plug devices. So things that have plugs, we still lock them out. If you notice right here, they got a lock out for pretty much everything you can think of, and that's we try to use it. Because we use this so that whenever you're wiring the motor up, there's no chance at all of anybody, plugging it up. In some cases, like in pipelines and all, you can't shut things down. You have to work on things hot. That's going to be policy of the company. And there'll be a whole pile of safety measures that has to be in place for you to work with something that's energized. Every company has got different guidelines and exceptions and stuff. Affected employee is anybody that's going to be operating or using the machine, or if you work in the area where the servicing is going on. Authorize the employee as somebody that can lock out or tag out a machine to do your maintenance. Energize means connected to an energy source, or it contains stored energy, or residual energy. Now here, there are lockout devices that can actually do breakers. So I'll show you what they look like. See in here, you've got a breaker panel. Individual breakers. What if you only want to work on, you've got a receptacle that's cracked and you can replace the receptacle? There's no point in killing the whole panel, is it? You can just lock out one particular breaker with some of these devices right here. So depending on what brand of the breaker it is, there'll be a particular lock device that will work on that breaker. So with this Square D has their own lock device where you can't cut it on. You put that on there like that, you can lock that one breaker out, and you're good. And then you're going to check voltage from that to ground and make sure that it is decent. But the way it works is this here, it pulls out like that, it slides on, you cut the breaker on, you shut it off like that, gets right over the top. There's a little thing that slides inside the hole. There's a hole drilled in that panel. So it locks into that, and there's no way to cut that breaker off. You put the lock, this tag, on there, you're good to go. So that's Square D. And then for GE, other brands, different type. Here you have a little window that slides like that. And that's on. It also has an indentation drilled in it. Here you have these tips that stick out at two different thicknesses depending on the width of the panel. And you find the one that fits. When you wiggle that in there like that, bring the window down, put your lock on there like that, and then you've got that one branch circle lock out. And then, of course, you put your tag on there to identify who's got it locked out. That's a handy thing to have. For double pole breakers, they got lockouts for pretty much anything you can think of. So here, you've got a 2-pole that could be right for a dryer or a stove, like that, double pole. Lock that thing out. And this is going to go on there. And it closes like that. So you put it on in the center, there's a little hole spot. You engage it like that, where the hole shows up. And you can put your lock on there with your tag, and you're good to go. But again, once you do it, you want to check with a voltmeter. The legs leaving it, go from each leg to ground and make sure that it is there before you go working the branch circuit. So, you want to pass these around, or y'all good? You want to look at them? Right, okay. So, I'll leave them here if you wanted to come by and get a closer look at the can. They're right there. Now, energy sources, there can be a lot of different energy sources on the machine. On one machine alone in a plant, you could end up having, water coming to it, steam. You could then, have hydraulics on the thing, electrical, chemical. There's all kind of stuff. And so every single energy source needs to be locked out and disabled and actually bled and drained, that there's nothing stored in the machine that can hurt you while you're working on it. So it would include, including gravity. Gravity, if you got something like a press or a meat dumper or something that's in the air, like a hydraulic thing that goes up and down, and it's in the air normally when it's in the home position, and you're going to work on it, but maybe you got a hydraulic hose that's leaking. So this device is up in the air that goes up and down, and it's up in the air. You're going to replace the hose. So when you replace the hose, it's likely that the thing's going to fall because hydraulic fluid is what holds it up. So if you're going to work on it, they want you to block it with something, put some big, pieces of steel in there, some 4x4 or something to block it. Because gravity does have an effect. I know somebody that got demoted where they worked at for a while because they electrically locked the panel out, but this thing had a hydraulic. It was a meat dumper in a food processing plant. They locked out the panel electrically, but they did not block. They didn't block the thing that could fall. It was hydraulic that made it go up and down. In this case, they were supposed to put a chain around something so it couldn't fall when they worked on it. But the guy forgot to do it. Well, they took him out of maintenance and made him a production worker, kind of embarrassed him for a few months, demoted him for a while, and then put him back in maintenance. So it was, it can be embarrassing, or electrically he did lock it out so that it didn't fire, So stuff like that can be a problem. There's a close-up of one of the breaker lockouts. If where you work at, if they don't have them, just ask them, say, can we get some? At least put a tag on there and say, don't open, at least until you can get some of these locks. Do something. Now, with valves, I showed you the swept blinds, those of you that were here. So if you have water valves or steam valves or any kind of valve, you put that over the handle. And then the stem is there, and then you can turn this, but you're not going to be able to grip the valve handle. So that's good, and they make them in different sizes. So, man, there's a lockout for pretty much anything you can think of. And if you ain't got one, you can do a chain or you can do something. Seriously, you can get creative with it. You got to have a designated type of tag, a standardized tag that is chemical resistant and all that's made for it. It's a really thick, rugged, laminated type tag. And your name needs to be on it. Your boss provides them, you don't provide them. They're supposed to get that stuff for you. So you're not supposed to buy that stuff yourself. There'll be an energy control program wherever you work at, supposed to be. There goes your slip blind right there. That's where your valve handles. So that would go for water, hydraulic, steam. It can go for ammonia refrigeration, any kind of a fluids whatsoever. Airlines. I mean, airlines, valves, to shut off the main air. Valves is like, there's lots of things you can lock out with that. Now, here's a case here to where they didn't use a slip blind, evidently didn't have one, so they did something called tag out. In some cases, tag out is acceptable, so it is an acceptable form to some companies. You just want to know what the policies are. Now, where I worked at, we actually had I had to inspect the sprinkler system once a month. Had to go actually open a drain valve and let the sprinkler drain and let it trigger the alarm and call the alarm company. And I would call and put it in test mode. We had 2 sprinkler loops in the plant. We had one in fabrication, one in our coat system. And so I would call the alarm company and say, put it in test mode for sprinkler. And so I go to the back and I would open up the valve and it would drain in the yard and then it would trigger. And I'd let it, for so long. Cut it off, and I'd go back in the other area and drain the other one. One of those, the valve handle was actually up within this far of the wall, and you couldn't get a slip blind around it. You couldn't because they had plumbed it in. You barely had enough room to grip it. It was so close to the wall, you couldn't get nothing around it. So I had to do a tag like that. I did a tag so that I had a tag on it, do not, don't touch it when normal operations, you're just supposed to be left open. You know what I mean? Nobody's supposed to be fiddling with it. I'm sorry, left closed. Supposed to be left closed. It was a drain valve for the sprinkler system. The drain was just to test the system. And that simulated a sprinkler head being broke. You know what I mean? And it would, anyway, when the system senses water flow, it calls the alarm company, calls fire department. But there are some cases, that's acceptable. And I was even told by one of our graduates that works at the Duke Power Plant in Goldsboro. That, and it's still hard to believe that he said that over there they don't use locks, they do tag out. And that there's a designated guy over the maintenance group that does the tag out, and the individual doesn't even do it, just doing the work. And I've never heard of that anywhere.
It sounds kind of unsafe.
I don't like it, but that's the way he said, that's the way they did it. But everywhere else I've been, you're the one that locks them out with a real lock. You're the only one that has to keep. But he said that where it's at a power plant where they use steam. They use steam. It's called a combined cycle plant. They use steam to generate electricity. And he said that they do tag out and no locks. And I don't know the reason. I actually went online a few days ago and read, and for Duke, it showed lockout tag out. It showed locks. But maybe where he's at, it may not be that way, or maybe they changed that. I don't know. It's been like 2 years ago he told me that.
But you could.
Mm-hmm. You can read the details. It's in Moodle, and I have it printed on paper. If you want it on paper, I can print it, and I think I probably will print it on paper and give it to you anyway. But that just complete thing is in Moodle. That shows a toolkit like I got that's got all these different devices for doing lockouts. You know, your boss is supposed to provide them. They got to be standardized color, shape, and all that stuff. They got to be strong enough that they're not easily removed. You know, cable ties can be used if you're going to do a tag out. If that's allowed, you can do the tag and the cable tie, and then you have to come back and cut it to get it off. You know, so depends on where you're at. Pictures is good to have on them. All that's saying that, you know, you get trained by your company. Affected employees must be notified when you get ready to lock something out before you do it. You got to let them know before and after, before the controls are applied and after they're removed. So here goes the heart of the matter right here. There goes your steps. So step one, and this is in your worksheet, you'll need to do a drag and drop in your worksheet. The last question, you do drag and drop, and you put these in order. They're going to be mixed. You prepare for a shutdown, then you shut it down orderly. Well, preparing for shutdown includes letting everybody know you're getting ready to do that. Get things organized, shut the equipment down in an orderly fashion, and then you isolate the equipment by, you know, doing the main power lockout, apply your lockout devices, put your lockout tag out on, and then your stored energy, if it has any bleeding. You know, you might have hydraulic, a line that needs to be cracked open and bled. It could be things like variable frequency drives that have stored energy in them. Some things like the VFD drives for motors, they store energy for 3 or 4 minutes. When you cut them off, they're not dead right when you cut them off. You got to wait, give it so many minutes, and then recheck it, make sure that it is drained down. So that's stored energy. Can be electric, it can be hydraulic, it can be air trapped in a system. If a machine doesn't have a dump valve, some machines, when you hit an e-stop, you'll hear the air dump and go poof, it'll dump. Some don't have dump valves. So check your gauges and make sure if you're going to be working on something air, look at your gauges and make sure that it's down. If it's not, find something a line you can crack open to bleed that line. Once you shut your main off, to bleed that line if it's got trapped air in it. And then verification that it is isolated by trying to see the ones, you know, you can get the button, see will it come on. I recommend taking a meter and checking voltage at the point that you disconnected it, maybe on the bottom side of your disconnect or breaker. Check voltage and make sure with a meter that it is big. That's the best way to do it. And then after you do that, go ahead and do your work, and then come behind that, releasing it from lockout, inspect your area, get tools out of the way, make sure things are put back together properly, guards in place. Make sure there's nobody around the machine. And before you restart it, let everybody that's associated with it, let them know. Some machines and processes are large, maybe as large as this room or bigger, to where one lockout can affect a massive area, and it'd be very easy for operators to be cleaning up, sweeping up while you've been working on something. And they might be in an area to where something's getting ready to start moving, a conveyor or chain or something. So make good sure nobody's around before you cut power back on. Know who your operators are, or the production supervisor, and be careful, especially on big spread out operations that use conveyors and all chains. Any questions? The lock is applied and removed by you only. Now, if you lock something out and then you have to leave, you get an emergency, you have to leave, and somebody has to finish that job, then your boss has authority to go in there and cut that lock. He's got to let you know before you come back to work that he's done that they've gone in there, they finished up the job. Where I worked at, the engineer had to have an extra key of your stuff. Now, some plants won't do that, or may not do that, but where I worked at, the engineer had another key so he could get in there if he went around. So, but they have to let you know before you get back what they've done. If you're going to do temporary adjusting, you're allowed to remove it, do your adjusting, and then cut it back on. Now, working with outside contractors and all. The plant you're in would comply with the outside contractor's rules on lockout tagging. If you got somebody coming in doing something, then their rules when they come in applies to when they're working. So you got to go with what they have. A group lockout, such as the one with a multi-hole, there'll be somebody responsible for a set number of employees. Let's say if you're on first shift and you can't finish the job, you're going to hand it up to second shift. So the orderly way to do it would be you get ready to leave, and it's going to take another hour to do it, and somebody's coming in to finish it up. So you let them, you show them what needs to be done, they put their lock on, and then you take yours off. So that way it doesn't remain unlocked at all. You just do an orderly trade-off that way, and they're responsible with the same exact thing. You get out of there. That's a safe way to do it. Of coordinating, continuity of protection. Got two locks on there. That's exactly what we're talking about. And that's it. So that's the gist of the lockout tag out. Okay, and go back to here. All of your protective stuff, your gloves and all that, your ear protection, eye protection. We've already been all over all that. Flame retardant clothing. I've showed you the lab coat we have, it's flame resistant. I'm going to show you what it says in here. It says fire retardant material is required in some areas. It is often required for maintenance personnel to work on high power sources, transformers, motor control centers, which is what this is exactly for this class. An arc flash in a motor control center can easily catch a person's clothes on fire. There's videos on YouTube of people, their clothes catching on fire. I'm not going to show you one of somebody burning up, but I'll show you one of an arc blast, just a brief one to show you just a little indication of what can happen. It's the reason why you're supposed to stand to the side of them. You cut them on and off. You need to have your clothing on if you're going to be in them. And it can produce energy to kill a person that could be 30 feet away in some cases. So let me show you a little quick little video, a little YouTube link. This is just a very short little thing here. The little folder I've got it in. In just a second, I've got it in one of these folders. And then ELC 111. Tri-state. Let me get the speaker turned on here. Sound bar. I'm going to cut the lights just for a second here.
Let's take a look at what happens when an arc doesn't sustain. We have a 30 amp disconnect with the door open here, and an arc that is less than one cycle, 0.6 of a calorie. In real time, you don't see much, if any, fire and little or no molten metal. But in slow motion, we're going to get a completely different appreciation. Let's take a look at what happens when an arc doesn't sustain. We have a 30 amp disconnect with the door open here, and an arc that is less than one cycle, 0.6 of a calorie. In real time, you don't see much, if any, fire and little or no molten metal. But in slow motion, we're going to get a completely different appreciation for how hazardous this event really is. This disconnect is really no larger than a toaster oven that you'd have at home, and yet in slow motion, you can clearly see how hazardous this event is. The arc flash itself projects over 3 feet, and the molten metal is being thrown 5 and 10 feet in more than sufficient quantity to ignite non-flame resistant clothing. Again, this is despite the fact that this is a very small piece of equipment and a very brief duration arc.
So it's only a 30 amp disconnect that did that.
Welcome to a normal working.
Now, I've never seen one look like that. I've heard something from a distance go off like a cannon, like more than one time. But I wasn't right in front of things that happened. I felt the things about it. It was the same plant that happened, and I had to go investigate it. So it doesn't happen a lot, but you need to be aware that it does happen. That at some point, if you stay in the field long enough, you know, something will probably happen wherever you're at some point. And just try to be safe and work around the equipment, especially when you open up a panel. When you cut things on and off. The rest of the stuff you can read on your own. On the GFCIs, we talked about that. We've already talked about that stuff. And if you actually wire the GFCIs up in residential class, we're not going to wire those. This is motor controls here. So we discussed why you want to have a GFCI from your power tools plugging them in. Just because you can have a little bit of current can leak through the ground like that. And the GFCI would know if there was less current coming back than it's sent to you. You know, it knows if there's something missing when it comes back. That's the principle behind the GFCI. is a leakage current, not overcurrent, but leakage current. That's a faulty coffee pot there, you know, to where normally there would be 10 amps, say, going to that coffee pot and then going back on neutral. If it matches the GFCI, it's fine. But if it senses that some of that current didn't come back, that's when it trips. If it goes on an imbalance of current, is what it does. So, but you wire these in residential class. If some of you haven't had it, but you'll have it in the fall. Yes, it'll be offered in the fall. That's a GFCI breaker, and then you have a GFCI receptacle. So if you have a breaker that's made that way, it can protect all of your receptacles, so you don't have to have those special receptacles. The house I live in was wired in 1977, and it has a GFCI breaker that's in the panel, and it protects the bathrooms and then the outside receptacles. You got plain receptacles there, but that was back, you know, in the 70s. Nowadays, you know, they'll have the receptacles that have the buttons on, and it's better because everything is separate. You know, if something trips, it only trips that one instead of tripping everything. Now, if I have something trip, it trips both bathrooms and the outdoor receptacles at the same time because it's the breaker that's doing it versus the receptacle. That's your portable version. If you don't have either one of those in some place, you can get those like at Lowe's, and they're portable. They work everywhere. So that's the thing to have for our guys doing work with power tools. The issue of grounding, you will see when you wire your circuits up that the transformers will be grounded and the motors will be grounded. So you're going to ground stuff, and that protects the metal parts of whatever you have, and it keeps the metal parts at ground potential. So if a hot wire hits something metal, then it ends up coming in contact with ground, and then it'll go ahead and trip a breaker instantly. If the hot wire hits ground, it's going to draw a lot of current really quick, and it's going to go ahead and trip or blow a fuse. But if you don't have your metal parts grounded and a hot wire hits the metal frame of the motor, the frame is energized and it's sitting there like a bomb waiting for you to touch it. When you touch it, it's going to try to get the ground through you because current, you know, electricity is always looking for ground. Like lightning, you know, lightning's always looking for ground. Anywhere it can get, it's going to try to get the ground. And so that's why your equipment, the metal parts, they always need to be grounded. Okay, so we're going to click on that in chapter 1. That was your safety chapter. Now, chapter 1. How many of you don't have a book yet? Okay, I've got a copy of chapter 1 I can give you. And there should be books still over there. Are you going to buy on campus? Order them on. Okay, order them online. You can say somebody like that. Anybody else? The books are over there. We got. They should be pointing I'm not going to copy every chapter, but I do for a few at the beginning. Do you have to get a book? So make sure that nobody's missing anything. Okay, so my scan was a little bit crooked where I scanned it on a copier to get the entire book in there. Now back in the early days of motor controls of industry, maybe back into Henry Ford days, you know, whoever was the first ones that did industry in the United here, things would have been, some things were run off of a steam engine that would turn something. And then they had it hooked up to a belt drive system with a common line shaft. So you had one steam engine turning, and then that would tap off of that line shaft to run different things. That was extremely primitive. That's way back. That's kind of the way things are done. Now, of course, we're way beyond that now, you know. Nowadays, you know, you got to have the ability to start, stop individual machines, reverse direction, increase, decrease speed, do braking, do soft starting, soft stopping. all that stuff you got to be able to do, and with the equipment that you learn how to wire up and run, you can fully control motor operations with a variety of things that you're going to learn how to wire and set up. When you're installing motors, you got different factors that come into play. Your power source is one thing that comes into play when you're installing a machine. Does the machine require single phase or three-phase power? And we're going to get into what does that mean. When we get to a diagram, I'm going to tell you what single phase means, and then another diagram for what does three-phase mean.
I use the highlighter up there.
Sure. Yeah. Yeah. Yes, sir. So you have things to consider about the power requirements. Does the machine require single phase or three phase power? What's the horsepower of the motors? How much inrush current do you have when the motor starts up? Like this motor here starts up this little pump. It doesn't start out drawing what it says on the nameplate. On the nameplate, it says about 8 amps. But that's the running amps once it hits top speed. When it starts up, it draws about 35, 38 amps on startup until it gets the pump going. So it draws like 3 to 4 times normal amps called inrush. And we'll demonstrate that right in here with an amp plant for you to see when we cut it on. It's going to shoot extremely high for a little bit, and as soon as it gets top speed, the amps come down. That's called inrush. So that has to be planned into when you install a machine. You've got to know all that stuff. And then in some cases, if you're above 100 horsepower, the power company won't let you hook. They won't let you start a motor directly off the power line. You've got to go through a reduced voltage soft starter like this to actually start that motor up extremely slow and very soft, so it doesn't have the inrush. So a soft starter is a mandatory from the power company if you go over 100 horse on a motor, or a variable speed drive, a variable frequency drive like this. So, when you get really big in motor controls, then the power company tells you what you've got to do because they don't want their grid to be loaded down.
So that's not supposed to be in there, right? Rated more than, right?
Right. It's supposed to be, yeah, that ain't right. It can't be right. I mean, there's typos sometimes in these books, and that's got to be a typo. It has to be. I've reported them at times, and every time I've reported a typo, then they agree. Every time I've reported one, I ain't reported one yet that they didn't agree with. That one I haven't reported yet. I just haven't taken time to get up with them. But every now and then I'll see one, and I'll get up with a company, and they'll say, "Yeah, you're right." They tried to pay me one time like $200 or $250 to preview a book. I just didn't have time to do it. I'm serious. They got it. Well, they wanted me to be a proofreader for the darn book company. I'm serious as a heart attack, man. I said, I ain't got time. Yeah. And making your motor connections, there's things that come into play: the horsepower, service factor, temperature rise, voltage, your full load current rating, all that stuff is printed on the name tag. And we're going to get into what does all that mean. What do you do with that information? That stuff you're going to learn as we go through this class. And when you pick your wire size, we're going to use a National Electric Code. I'm going to give you certain selected code sheets. It'll help you know what size wire do you use for each motor and pick it and be completely safe. How to pick the right size wire, the right size fuses and breakers. We go back to the code book, and there's specific sheets that you get that I give you, and they're referred to in the book for making those selections. And the controller types that we use, You know, it can be a standard motor starter like this, a magnetic starter that just pulls in with a coil, energizes a coil that pulls in and runs the motor like this instantly. And then you have the soft starters again that are very good. And then you get more elaborate with a variable frequency. You got a lot more features with these. So you're gonna hook up all of these and program, test, and troubleshoot. All of this stuff is what you're gonna be working with this semester. They talk about, you know, machines that have to start up a heavy inertia like a flywheel or a centrifuge or something like that. So if you got something like well, Eric, have you seen punch presses at Hog Slap? Mm-hmm. Punch presses, they have like a big old flywheel. A lot of the older ones do. And that flywheel it takes it a good 20 or 30 seconds to ever get up to top speed when that motor starts. When it starts out, it goes, and it'll for about 30 seconds. Now, while it's doing that, your amps is like super high. That is if you started out using a regular magnetic starter like that. It's an instant start. It's like a hard start, you know. So if you switch off and go to a soft starter in the program, you got switches in here that you can set your ramping time. If you want to give it like a whole minute to ramp from 0 to the top RPM, you go in there and flip these switches and you set it for a minute or 30 seconds, and that's what it'll do. And what will happen is if you get rid of that high end rush, it reduces it a lot. It reduces it a lot. You can pass this around if you want to. This is a soft starter, and this is one you'll wire up later on. That's a regular magnetic starter that has a coil. When you energize the coil, it pulls in all the contacts, and it's a right now hard start. It's just a boom, right now, no delay. You know, this is a variable frequency drive that has top speed on this can be any particular speed that you want it to be. With a soft starter, it will start up slowly and it'll ramp up nice and smooth, but when it gets top speed, you're stuck with top speed. You can't change top speed with a soft starter. With a variable frequency drive, you can do the ramping, but when it gets top speed, you can program it to be something less than top speed. You can make top speed be anything less than top speed. Be half of it, a quarter of it, 3/4, whatever you want. You dial that in, and it's always adjustable. It drops the hat. So you get into all that stuff. You get really familiar with all this stuff in this class. Some motors have to have a physical brake on it. We've got a brake motor that you'll wire up, and it actually has a brake pad on it, an actual disc brake on the back of the motor. So that when you de-energize it, when you cut the starter off, that it actually will slam that motor shut and with a dead stop. Now that's not used a lot, but at Butterball, you know, they sent one over here. We've got one out here that'll do a hard stop, and it's for precision stopping in a particular place with no drifting. So that's something that you know that in some cases is required. The environment that your equipment is in will determine the type of equipment in the enclosure. Some motor starters are regular general purpose, you know, general purpose type of an enclosure. Some are explosion proof like this. So let's say if you got in a gas pump, they got to have explosion proof motor starters for pumps. If you work in a feed mill where where dust can actually explode and blow up a feed mill, you got to have explosion proof type components near the dust. All that dust, or else it could explode and kill people. So explosion proof enclosures is there. You got to have them in certain places. You know, where I worked at, we had a flash off room that our product went through before it got dipped. And it was alcohol and primer mix. And so the products went through there. Well, all of your push buttons and all your e-stops and stuff, it was in the alcohol area. But all of it was actually the explosion proof push buttons, and it was all really beefed up stuff that there was no sparks. Everything, the enclosures, instead of them being thin like this, the walls were like this thick on them. Special, that were, explosion proof, as they say. Some things are general use, some are dust proof, some are explosion proof. Underwriter Laboratory, they rate equipment. So before somebody puts something on the market, they'll send the product to UL, and UL will test it, and they'll stamp it if it's safe for the environment that they sell it for. And so if you look for a UL stamp on equipment, and that tells you that it's been tested by a lab that says it is safe to use in a particular place. National Electric Code, we're going to be using portions of that. And then NEMA is an organization, National Electrical Manufacturer Association, NEMA. That's one you're going to be hearing about a lot. They set up standards for equipment manufacturers to go by. Let's say, for instance, if you had a Schneider motor starter and an Allen Bradley motor starter, if both of these companies are a part of NEMA, where they stick with NEMA standards on how they rate their stuff. So if this starter here was a NEMA rated 1, a NEMA size 1 starter, and then Schneider, they compete with Allen Bradley, of course, whatever Schneider has, if it says it's a NEMA size 1, that means you could get a Schneider in the place of the Allen Bradley, and it will do the same job. If it's NEMA rated with a certain number, then you could say, maybe I could go cheaper if I get Schneider, or maybe I couldn't get an Allen Bradley, they were never out of stock. So you tell your supplier, well, just get me a NEMA size 1, whatever brand you got, just give me something, and then it will work. As far as it can handle the same horsepower motor if it's a NEMA 1 or NEMA 2. So that's where the NEMA comes in, and there'll be NEMA ratings on the stickers. There'll be, and that makes it so that a bunch of companies can be rated in a consistent system. And and motors are that way too. Maybe if you can't get a Lincoln motor, maybe let's say that you have a ball door motor. Do you have a Reliance motor that I can get that's a certain horsepower, certain frame size, and all that stuff is NEMA standards too. And so that comes into play. So NEMA is very important in the U.S. If you're anywhere else in the world, IEC sets up standards for the rest of the world. And so equipment that comes in from overseas is built according to IEC standards, not NEMA. So those are your two standard companies or organizations that equipment is built to be consistent on how they rate them. Now, on control systems, now I've got this here marked up like crazy. I underline and highlight it. It looks like, my God, what is doing here? Motor control systems can be divided in 3 groups. They can be divided in 3 groups. You have manual controllers, you have semi-automatic, and then you have automatic. Now, for manual control is something as simple as this. I've got a manual motor starter that looks like a regular wall switch, but it's just a heavy-duty version. That is a manual starter that will connect the motor directly to the line, directly with this switch here. Now, with this one, it's not just a regular switch. It has it's got a thermal overload inside of it that will trip if you get too many amps, if it pulls too many amps. I'll just show you how heavy duty it looks inside. And that's what's used on this hydraulic unit right here. It's the same thing. You look right here. That right there. That's a manual starter. So just a heavy duty toggle switch. I'll pass it around. It has a switch mechanism there. These two screws are the switch. So if you check this with an ohm meter, it'll ring and then it won't. That's your switch. That spring looking thing there is actually a thermal overload. If that's in series with the switch, then what happens is if this thing senses that you're drawing too many amps, what it'll do is it'll throw that switch to the center like a breaker trip, and it'll be loose like a breaker trip. And you gotta let it cool down and then retop it and then reset it after cooling down. So I'll pass that one around. See how heavy duty that is? That's a manual starter. Yeah. It's just done by connecting a motor in series. Yes, sir. Thank you, bud. Thank you. Good man. This is a basic way to hook up a single phase motor. Now, a single phase motor has two current carriers. You can just make a note on that. Single phase motors they'll have some type of protection in here, circuit breaker, and then you got a switch. And they're in series with the hot wire for the motor. So you got power going to the motor, it goes through the windings, and then it comes out, that wire goes back. Now, if it's a 120 volt single phase, it has a hot wire and then a neutral wire. The current goes to the motor on the hot wire, and then it comes back and it goes back to the panel on the neutral wire. If the motor is a 240 volt single phase motor, and this motor right here can run 120 or 240. It can run either one if you wire it correctly in here. I'll flip that around. Depending on how you configure the wires there, it can run on 120 volt right off the wall, or it can run on 240. Okay, and that information is given with the motor itself. It's done within there. It's shown on the motor, and I'm going to give you a paper that shows it. But this would be like a pictorial of that circuit. This is a schematic diagram that represents the pictorial. So you're going to go from pictorial to schematic. That's the official symbol for a circuit breaker and for a switch, and then that's for a motor. So this is a neat way that you do it when it's just a schematic diagram. That's what you're going to get used to reading. Now, for instance, right there, I'm going to give you something to let's take a look at how would you wire that single phase motor. How would you wire this motor on 120 volt, and how would you wire it on 230 or 240? So let's take a look at the front sheet, and then it's going to show you your dual voltage hookups on the second sheet. Let's take a look at that and make sure you understand that. These motors are used on farms for fans. They're used in plants on small things, small loads. And this is going to be like what you first landed. I got some motors like that that'll be sitting on the table. And you're going to change them from low voltage and high voltage, and then take them reverse direction. So there's information in here on how to go low and high voltage, and then also how to reverse the shaft, make it go down. The second page is included. It's actually a picture of what's on the name tag on the name tag. Second page. Nathan, I'll have to put this on in Moodle for you because I don't have it. I don't think I've got it even on the computer. I don't think I've got it scanned. I don't think I do. Let me check this. Let me just double check and just see that I have it. I may have it. I scanned it last year. Sure did. There you go. All right, great. That's wonderful. Okay, so Nathan, you're good to go. So this is showing here a basic schematic of this hydraulic pump. This is a basic single phase hookup that we're looking at. The switch enclosure has the switch itself, a normally open switch, and it has a overload heater. It looks like two fish hooks that are back to back. So that's a symbol for a thermal overload. And what happens when it gets above a certain number of amps going through that element, it will actually make the switch flip and trip, like it will be spongy like the breaker was tripped. Okay? So where is the little manual switch? Did he bring it back up? Yeah, there you go. Yeah. I'm gonna show it to Nathan. Is on the he ain't live, but I guess he'll be watching recording. Let's see. Yeah, he ain't on, but yeah, I'm recording. So anyway, but this is the actual physical switch here, and you can see the thermal overload is a spring-looking thing, and the switch is right in here. So it's just a beefed-up toggle switch with a thermal overload. Okay, so the schematic shows just the switching device and the overload. It shows a hot wire, a neutral wire. Now, if this was, say, 230 volt or 240 volt, instead of it being hot and a neutral, it would be two hots. It would be two hot wires, and when you put a meter across these two, it would say 230 or 240, and there wouldn't be a neutral. And that same motor can run low or high if it's a dual voltage motor like what you're looking at. That one's dual voltage, and most of them are going to be dual voltage. They sell more motors if it'll work. Yeah, it's dual voltage. Yeah. Yeah. Yes. That's how you know it's dual voltage. Yeah, it can run low or high. It can run on a wall receptacle. It can run in a hog house, chicken house, turkey house. It can run for fans or whatever you're running it on. So they make them dual voltage so that they can sell a lot of them, and it can work. They're not you know, if they're dual, you can sell a lot of them. So again, the difference between the power source would be two hot wires. That will be a L1, line 1, and line 2, and they're different phases. They're not the same exact identical power leg. If you have 230 or 240 volt, it would be two hot legs or two phases that come from a three-phase system that has a L1, 2, and 3 for three-phase. Three hot legs that are timed different in the way that they're generated at the power plant. They have a different swing to them in the way they're generated and the way they come to you. So you take the first two legs out of a three-phase system and use it on high voltage single-phase motors, like on farms and places like that, and it would be the L1 and the L2. Now, the way you configure the motor is what we're going to look at now, and that's what comes on the data plate. So here goes your hookup. Low voltage line and high voltage line. So if you go low voltage with this motor, line 1 would be hot, and then line 2 would be neutral. It doesn't say that, and the motor doesn't even care which one it is. The motor will still run, even if you hook it up neutral and hot versus hot and neutral. The motor doesn't care, and it won't change the direction of the motor on single phase. It's still going to run the same way. So you take your hot wire, this right here, that one going in there, and it comes to a black, a white, and a yellow that's in the cat head, what we call the cat head. It goes butt size of the cat's head right here. They call it the cat head. Somebody call it that. I don't call it that, called cat head. There's some place you'll find cat in there. I've been there. You see a cat out.
motors after they shut down and stuff. They'll go in there to warm up and stuff.
Oh, really?
Yeah. I worked at Dubos years and years
I
ago.
thought that's where I recognized you.
I worked at Dubos years and years ago. And every time there's cats all over.
Yeah, there's cats everywhere around there.
And you can go in there one morning and get ready to.
In the plant?
Yeah.
I guess because
Because the doors just stayed open.
Yeah,
for all the truck drivers and stuff. Yeah, burglars everywhere.
I found a snake in the 40-foot base.
So before you crank anything up, you gotta check everything.
Right.
You might hear that.
Yeah, y'all ever find a cat in the bay where y'all keep on the big old sheet set?
We find them all over the place all the time.
Dang. Yeah, in the torch area, they keep on the big old 1-inch sheets in this little, like, it's like a, what would you call it? It's like a in-ground thing.
Yeah.
And, man, there was all kinds of stuff in there.
Okay, now,
I thought I
so
recognized you, man.
within the cab head, you got 6 wires. You have 6 wires plus ground. So you would do black, white, yellow, and that dot was going to represent a wire nut. You put them 3 with your hot wire coming in with a wire nut. So here I've got 2 wire nuts. So if somebody wants to volunteer, you can come up here and wire this thing, okay? And so we can run it. You want to do that. 2 wire nuts, and everybody's going to wire it anyway. I got more motors out there on the table. We'll let you wire. We'll start doing our hands-on tomorrow. We'll start doing our hands-on tomorrow, wiring stuff and seeing it run. So with this one, there's 6 wires in there, and then the ground.
Can I ask a question real quick?
Mm-hmm.
If it's underlined, that means that's the ones that get done. They get connected. You said black, white, and yellow, so I'm wondering.
Yeah, those three hook up to your main hot leg. Let's see. They all go together. There's 3 wires plus the incoming hot wire, which will be 4 wires together. That's the wire nut. The dot is the wire nut.
Okay.
You put 4 wires in there, and you twist the wire nut, and that's your first connection.
I was just saying. I was just making sure. If it's underlined, that means that's the ones that get connected.
Yeah, that's the actual wire. That's the actual wire itself. Yeah.
I just want to make sure I was clear.
Mm-hmm. That's right. Here, your neutral wire, which would be this one, it says N. If it's low voltage, it's going to be a neutral wire, which would be 0 volt neutral wire, and it goes to what? Blue, orange, red, and they're also labeled T1, T3, T8. So there's T labels that are stamped on the wires and they're color coded. So if the T numbers are rubbed off, the colors are still there. Okay? Okay? So so how many wires is in each wire nut? There's, counting the incoming wire. 4. There's 4 and 4, 2 wire nuts, and then the incoming ground wire, it goes to the frame of the motor. It goes to the frame. So it has to be bolted with a ring tongue connector, and it has to be bolted to the frame of the motor. Ground when required, and it's always required. So I ain't never seen it not be required. Now, what if you have, this is the data plate, this is GE, that's your part number. If you had to replace the motor and you go to get one, you just take your phone, snapshot the data plate, call your supplier, or either shoot him a picture, say this is the motor I need, and you give me a GE or give me whatever you got. As long as it matches, if it's half force, dual voltage, if the RPM is important, 1725, it can't be a 3450. They do make motors, blower motors that run double that. It'll run 3450 RPM. Now that'll tear something all to pieces, a pump. You don't want to do that. So the motor can look just like it. It can be a half horse. But that RPM, you better be right with that. Or you're gonna have a heck of a mess and might not have a job or might get sent home a while. Or you might be in the hospital because it might swing something out, you know. So RPM, and then so it says the voltage, it says 115/230. That means it's dual voltage. It means it can run on 115. So why does it say 115? 115 is the middle ground between 110 volt and 120. So at my house, it runs 120 or maybe even a little hotter. Some houses it might be 110. So 115 is your middle ground on your voltage. 230 is actually the middle ground between 220 volt and 240. At my house, it actually is close to 250. So our power that goes to our heating and air and all the dryer and all, it's around 248 volts. It's hot. And it's the transformer on the pole that the windings on it, that they're hot. And they're, you know, that's what we get coming in, and that's the particular output voltage of that transformer. So, but where you're at, it may be 220. Well, they're going to rate the motor in the middle ground of what it could be, and then the amp rating, the amp, this motor would draw 8.6 amps at 115 volts. That's once it hits top speed, once it gets beyond the inrush and it gets to 1725 and it levels off, then it's going to run at 8.6 amps approximately. Now, if you double the voltage and go to 230 and you do the other wiring configuration over here, then how many amps does it draw? It draws half that much. So when you double the amps, the motor doesn't guzzle as much current. Okay, so it's half the amps if you double the voltage, half the amps. And that's always the case with a motor, whether it's a single phase motor or a 3-phase motor. When you go high voltage and you double the voltage, the amps drops in half. Okay, so you got to know that when you're troubleshooting with a meter and you're checking the amp draw, and you go to this thing and you're checking the amps and you say, well, how do I know if that's right what I see on my meter? Well, you go to the data plate and it says, you got to know, number one, are you running on 115 or 230, and then you go to whichever amp rating that it's rated for. And that's how you know, are you in range or not on what the motor's pulling. Make sense? Okay, so that's your dual voltage and your amp ratings that correlate with those two voltage ratings. And here for pH, that means phase, and when it says pH1, that it means it's a single phase versus 3-phase. And then the hertz, HZ, is hertz 60, which means that the power coming in from the power company has to be 60 hertz or 60 cycles per second. And in the US, it is 60 hertz. If you go to Europe, it's 50 hertz. They generated at 50 hertz in Europe, so that motor would not be rated to go overseas. But then some motors are actually rated 50 or 60 hertz, and it'll say it on the nameplate. So some motors will say 50/60. And there'll be a rating. So you can get motors that are international type motors, and they'll be rated both ways. So, and also the frame size. If you're going to go replace this motor, it's a GE. Maybe you couldn't get a GE. You could get and the supplier says, well, I got a bow door. Would you take a bow door motor or a Lincoln? And you say, here's your critical things. Horsepower has to match, voltage has to match, RPM has to match, and frame size has to match. So this is a FR frame size of 56C. And what that has to do with is does that motor, does it mount down here, or is it a face mount? Some motors are actually bolted in for the face, like a C face. So the NEMA sets up standards. That 56C is a NEMA designation. You see that word NEMA? NEMA designation is FR frame 56C. So what that means is that the mounting dimensions, the distance in inches between the centers on the bolt hole, from the slots when you mount it, you measure those slot distances this way, and also between the slots that go this way, it's a 56C mounting pattern footprint. And if it's a ball door or a GE or a Lincoln, if it's a 56C, any brand will work. And also, the physical size of the motor is supposed to be similar too. If you're supposed to be able to fit that motor in the enclosure or the cabinet or the guard or whatever, it's supposed to work regardless of the brand if it has the same frame size. It's supposed to work that way. One time I saw one that did not. and it was because of the height. It was a difference. It actually bolted on, it bolted in. The footprint was the same, but then the height, because of the start capacitor, the cover would not go on. And that was, you could double check that stuff by asking to check the height of the motor. That's one thing you can't have. I know it's time to go, but so tell me, what do you do? What do you do if you're going to hook it up, say 230 volt, high voltage?
You're gonna go with the black, yellow, your hot, red, white, orange, is gonna be your.
Right, your hot wire coming in, your L1, your hot wire L1. Smart, the ink ain't available for this.
What?
But look, here, your hot wire, your L1 coming in from your switch, it would go to what?
Black and yellow.
Black and yellow only. They would be, then you got, say, three wires, right? What do you do? What does this here mean? They get wired together and they don't hook to no power line. They just go together with a wire and they're isolated or insulated. They're insulated. And then what do we do with the second hot wire coming in? It goes to blue only. It goes to blue only. Everybody in here is going to hook up the motors that way. I've got two motors like this that are just sitting on the bench out there. And I'll have a little short pigtail, and everybody goes through and hooks them up high, do one high, do one low. And it's the same motor. It's the same motor, but you change the configuration of it. Now, what do you do? What do you do if you want the motor to actually go in the opposite direction? Who can tell me that? Connections shown are for CCW, counterclockwise rotation, CCW. Viewing the lead end of the motor. If you want to go CW clockwise, what do? You interchange the black, J10, and the red, or T8. So, listen close. Here's what you do. You don't flip the incoming wires like you do with three-phase. With three-phase power, out of the three legs, if you flip any two, the motor goes the other way. But it don't work that way on single phase. On single phase, you got to go in here and you got to take the black one out and the red one out, and you got to switch them into other bundles. And you say, well, same thing. It says for either voltage. Over here, take the black out and then replace it with the red. You switch what bundles that they're in. You say, why is that? And the reason is because of this. In a single phase motor, you have a start winding and a run winding. You've got a coil like a winding. So the start winding has two wires to it. It goes in, it goes through a coil, comes out. You got another coil that's called a run winding. Your start winding is black and red. And when you flip black and red, and you don't flip the run winding, and you just flip the start winding, it kicks off the other way. So you're reversing the start winding within the motor because the start winding leads are red and black. And you're leaving alone the run winding as normal, and you're flipping polarity on the start winding. And that's it. So I'm gonna hush, and we'll take up here tomorrow. We'll let you wire these motors, and then we'll move on to three phase. And you're gonna learn a lot. Just try to be here every time, and stay on top of your modal assignments, and go ahead and read ahead.
Do we have anything else besides what we got for tomorrow?
Not yet. Thank you for coming. Just try to be here every time and get it all. And
I came in kind of late.
okay. I haven't even marked it. See, I'll go get marked. Alex, Brandon. Was Zachary here? Zachary Fan, I don't know if he was or not. Was Zachary here? Yeah. He was.
He was, I mean.
Eric, Wood, Daniel, Taekwon. Taekwon won't here, was it?
I don't think it was here.
He won't be here.
Went and got Mickey. He tried to pick up the 4x4s
Cameron and R. He was here. Yeah, I know he was.
Yeah, man. I was there right after you. Because remember after that drug test stuff. And whatever the new company was taking over.
Oh yeah.
They laid me off.
Oh, did that?
Yeah.
Yeah, I literally, you know, it's in the store, if they have like highlighters and stuff like that.
I'm sure they do. I'm almost positive they do.
Cause I bought the crap out of that while I was up there.
Mm-hmm.
I read
Yeah, I use them like crazy too, man. You know, you sure need to. It's good to have.
I wrote down about everything. I labeled what everything
Mhm.
means, and I kind of labeled like that's
Mhm.
a hod where it can be flipped.
Yep. Mhm.
I like looking at this kind of stuff.
Right. You're gonna get a lot of it. Just get ready. Just get ready. I got a pile of it, and I don't run out neither.
Oh yeah.
I don't run out. Like the Lord don't run out. I ain't gonna run out. I got a box slam full of stuff in here, and you only have a very few people that actually do all of it, right? But if you're here each time, you go for it, you will do it, right? Yeah, that's what.
Yeah, I got a feeling I'm gonna like this. I
Oh,
like
you will.
most girls like
You will. You'll like it better than you will residential. I think you will. You make more money.
I like hearing about stuff.
Good. You'll get into it. You make more money at this.
On to the
Okay, so Nathan, we're signing off, buddy.